In this video, we'll learn about polynomial representation using linked list. This topic we have already covered in arrays. If you have not seen that video, you can watch it, polynomial representation using arrays. So now let us represent it using linked list. Here is an example polynomial. This is a univariate polynomial. It is defined in terms of just a single variable x. So it is summation of terms. There are more than one terms being added together. If we know the value of x, we can evaluate and get the result of that polynomial. We want to represent this in our applications. So for representation, we have to store the data about that polynomial. That data can be stored either in an array or linked list. So array we have already seen. Now how to represent the data related to polynomial in a linked list. So if we observe a polynomial, each term is having its coefficient and exponent. Then if we know the value of x, then we can raise the value of x to the power, that is exponent, and then multiply with coefficient. So we can get the answer for just one term. Like that we can evaluate all the terms and get the result. So it is sufficient to store coefficient and exponent of each term. So these terms we can represent them in the form of a linked list. So for that, we can define each term as a node, and these are set of nodes. So let us define a node for one single term. Here is a node having coefficient, exponent, and a pointer to a next node. Let us define a structure for this one. This is a node having integer coefficient, integer exponent, and a pointer to a next node. See, I have taken integers. If you feel that coefficient is a float, you can take float also. Now one more thing you can observe. This is a node of a linked list and is having three members now: coefficient, exponent, and a pointer. So far, whatever the linked list we have studied, that time we were taking only one value. But now we are using a linked list. So based on the requirement, a node can have any number of data members. So now let me represent this polynomial as a linked list. Here I have a linked list of these type of nodes where each node is having three sections. This is for coefficient, exponent, and a pointer to a next node. So there are four terms in a polynomial. I have taken four nodes. Let us fill up the values from that polynomial. First coefficient is 4 and the exponent is 3. So this is 4 comma 3, and this is 9 2, and this is 6 and power is 1. So 6 and power is 1, exponent is 1. That is 7 and exponent is 0. That is 7 and exponent is 0. This is how it can be represented. If you remember, in arrays, we were also storing how many terms are there. Here we don't need to store. If you want, you can store it somewhere else. Otherwise, the number of nodes are equal to number of terms. We will not have any extra nodes here. So that's all. This is the representation. Now we will learn how to evaluate a polynomial. Already we have a polynomial, and this is represented using a linked list using this node structure. Now if we know the value of x, then how we can get the result of this polynomial? If suppose x is 1, then this will be 4 plus 9 plus 6 plus 7. If x is 2, then it will be 4 into 2 cube plus 9 into 2 square plus 6 into 2 plus 7. That's how I have to evaluate this one. I will show you the procedure and also write a function how to evaluate this one. Let us look at a procedure. Suppose I know the value of x. X is something, let us say 2, 3, whatever it is. So for getting the result of this polynomial, I should raise this 2 to the power of 3. I should take 2 power 3 and then multiply the result with 4. Then go to next node. Then 2 power 2, multiply the result with 9. Go to next node. 2 power 1, then multiply the result with 6. And then they go to next node. 2 power 0, multiply the result with 7. So I have to scan through the linked list. At each node, I should raise the value of x to this exponent, and the result should be multiplied with this coefficient. And add all the values, I get the result. So the procedure is very simple. So I will write a function here for evaluation. Here is the function. Function name is evaluation, that is eval I have taken, which is taking a parameter x, the value of x. Then I have some temporary variables, that is sum, for finding the sum of all the terms. and I have taken a pointer q that is pointing on p. I have taken the name of the first pointer as p because it's representing a polynomial. So q, I am taking it as a temporary pointer for scanning through this list. So q will be pointing here. So q will be accessing a term and moving to the next term. In this way, it will scan the whole linked list. So let us do this process. So we know well that whatever the value of x, that should be raised to the power of this one. So find out power of x comma q's exponent, that is q's exponent, q caps exponent. This will find out the power. Then this should be multiplied with q's coefficient, this coefficient, that is coefficient. So q's coefficient. Then this result, whatever we get just one term, and this should be added in sum. So sum plus. That's all. This is the expression. It will evaluate one term. Then I should move q to next term and do the same thing. Q assign q's next. So q will move to next node and again repeat the same thing. So I have to repeat the same thing means it should be in a loop. So I will write a loop. How long this loop should work? Until q becomes null. So while q is not null. While q is not null. While q not equal to null. Continue these two steps. That's all. This will evaluate a term, move to next term, then evaluate a term and move to next term. Then finally return the result sum. So that's all. In this video we have learned how to represent a polynomial and how to evaluate a polynomial. Now adding two polynomials, that is a student exercise. We have already seen that in an array. So here upon a linked list, it will be similar only with some minor changes because this is a linked list. So you work out on it and write on the program for adding two polynomials, evaluation of polynomial.